Understanding hash tables.
Hash tables are a popular data structure that stores key value pairs, allowing fast data lookup, insertion, and deletion. They work by applying a hash function to keys, which determines where the values are stored in an internal array. Their speed depends on how well the data is distributed inside that array, making design choices like the load factor very important.
What is load factor?
The load factor is a measurement that shows how full a hash table is. It's usually calculated by dividing the number of stored elements by the total number of slots in the table. For example, if a hash table has 100 slots and 70 elements, the load factor is 0.7. This simple ratio plays a big role in hash table performance.
Impact of load factor on efficiency.
A higher load factor means the hash table is more crowded. As a result, more keys may compete for the same slot, leading to collisions. Collisions make operations like searching and inserting slower. On the other hand, a very low load factor wastes memory. Managing the load factor is about finding the right balance between speed and space.
Resizing and rehashing.
When the load factor goes beyond a certain threshold, the hash table must resize itself to maintain good performance. This process, called rehashing, involves creating a bigger table and redistributing all stored elements according to a new hash function. Resizing ensures that the load factor stays in an optimal range, keeping lookups and insertions efficient.
Choosing the right load factor.
Many hash table implementations use a default load factor of around 0.7 to 0.75. This strikes a good balance between memory use and speed. However, the best load factor can vary depending on your application. Understanding and tuning this value allows developers to optimize hash table performance for their specific needs.